Today we will be discussing calculus. Calculus, it is a mathematical tool which is very important for physics. This calculus, it forms the building blocks, and right here it forms the building blocks of physics in class 11 and 12th. So what is calculus? It is the mathematical study of changes. Right, changes means it can be like any change. So they are of two types. The first one is differential calculus, and the second one is integral calculus. Integral calculus. Right. So they are used mainly in graphs and to solve numericals. Let's start with differentiation first. We'll be discussing the concepts after this. So the basic form of differentiation is, it has a basic form in which we represent this thing. It is called, wait a second, I'll show you. It is exactly called dy by dx. Now don't be scared or confused. What is this d thing? We can't cancel d, we can't do anything with d. I'll explain. Suppose we have a graph over here, and here's a straight line, and about I mean, it's a small change. Here we have a small change. This small change will say like dx or dy, anything. So here, we all know that delta y means small change in y, right? Small, I'll write over here, change in y. Delta x means small change in x. So here dy, here dy, these things means very small change, in x. Very small means like 0.0001 or like this, like very small, it's very small. So, and similar way, same way, dx is very small change in, it will be y, sorry, I mistaken it over here, it is y and it is x. Very small change in y, very small change in x. Okay, so when we write exactly this thing, dy by dx, we mean very small change in y with respect to very small change in x. We read it as, see, differentiation of y with respect to x. Like a very small value of y is being changed with respect to x, right? I hope it's clear to you. Now If we take a graph into consideration, like if I try to draw a graph over here, right, and suppose we have a curved line, this thing, curved line, right, and if we are asked to find slope, we just can't find it directly. Like if we are asked to find slope at, suppose at this point, we can't find now, because like it's slanting, we can't apply here tan theta. I hope you all know that slope is equal to tan theta, right? So what we do here is like we take a very small section of this graph, like at a particular point we are asked to find the slope at this point, right? So if we cut a very small portion of this graph, like if I try to cut only this thing, we know that this is a curved line, this is curved, but for this respect, only for this line we can take it as a straight line. Because see, if it is like if here I draw a curved line and I zoom it to very big, I can find it's a straight line. The same concept is applied over here. Here if we take a very small change or very small section of this thing, from here we can find slope, right? Let's move. Here we have the graph. One second, sorry. Here's the graph. If we take this portion, only this portion, for this respect it is a straight line, this is a straight line of course, and we will be calling for our convenience this thing d, we will be calling this portion as dy, this portion as dx, right? Dy or dx, let this as it's the y-axis and it's the x-axis for that reason. Okay guys, so for this region, if we extract it over here, we can find a similar triangle like this. It is dy by dx and the angle is here, it's angle theta. So we can say, and if this angle is theta, then we can say that tan theta is equal to dy by dx, right? So this differentiation, it is used very useful to find the slope of a curved graph, like it's curved, but with the help of this differentiation we can find the slope at any point, like we can take any section, anything we can take and we can find the slope of it at a particular point. So here tan theta is the slope, so we can write, we can conclude that, one second, we can conclude from this which we learned earlier, that see, dy by dx is equal to tan theta is equal to slope for a graph, right? Tan theta, this thing is also, we can write it as slope of tangent at a point, because from this point we take a tangent, right? From this point we take a tangent over here. For that reason we call it slope of a tangent at a point. Now this may be it may seem like very confusing, very hard to you, but don't worry, with practice we'll get used to it. So there are some basic formulas for differentiation. So I'll write them. Basic formulas for first derivative. Here, by the word first derivative, I try to mean first differentiation. Okay, like here we have some formulas which we have to learn it by the heart. First one here is, if y is a constant. Okay, so y can be any number, like y can be equal to 1 to anything, 0, -1, anything, y can be anything. So we can say dy by dx is 0 if y is a constant. If y is a constant, then we can say dy by dx is always 0. Note this down. This is a very important formula. It is the first formula, right? Next we come to another formula. When y is equal to x to the power n, right? If y is equal to x to the power n means y is somehow related to x, then we say dy by dx means differentiation of y with respect to x. It is, the formula is n into x to the power n minus 1. Just note this down and try to learn it. We'll come to these sums after this, right? Third formula is y is equal to e to the power x. Here e is a constant. It has some specific value 2.71, which will come to know after this, later on, not right now. 3 here, dy by dx, where y is equal to e to the power x, is ex. Means they remain same. They don't change. If we differentiate ex with respect to x, it remains ex only, e to the power x. Now next we come to the fourth formula. This when y is equal to ln x, this is a good term. Here ln x, this ln means, I'll explain you. ln x means ln x is equal to logarithm of x to the base e. Right? Just simply learn this thing. When y is equal to ln x, at that point of time, at that instant, we can write dy by dx is equal to 1 by x for sure. Just don't worry. Just close your eyes and write down this thing. When dy by dx and y is equal to ln x or log of x to the base e, at that point of time dy by dx is always 1 by x, where x has a certain value, of course, obviously. Fifth formula, when y is equal to sin x. When y is equal to sin x, at that point of time dy by dx of, when y is equal to sin x, the differentiation value is cos x. Again, it's a formula. Just learn this thing. We'll come to this thing after this. Don't worry. Sixth formula, where y is equal to cos x. Here you will be thinking that dy by dx is equal to sin x, but no, guys, you are wrong. The differentiation of y with respect to x, where y is equal to cos x, is minus of sin x. It's an important formula. We encounter this a lot of times in physics. Just note this down. Next we come 7, which is when y is equal to 10x. At that point of time, when y is equal to 10x, then dy by dx is equal to sec square x. Right? Just note this down. We come to the next page, and here the next formula number 8 is when y is equal to cot x. When y is equal to cot x, then differentiation of y with respect to differentiation of x, where y is equal to cot x, is minus cosec square x. Just simply note this down and try to learn them by the heart. Next formula, when y is equal to sec x. When y is equal to sec x, at that point of time, dy by dx will be equal to sec x into 10x. Sec x 10x. Note this thing down. 10 become the last formula for now is y is equal to cosec x. At this point of time, dy by dx is equal to minus cosec x into cot x. Here there I have given you 10 formulas. I'll show it from the beginning so that you can see all these things. When y is a constant, then dy by dx is 0. When y is equal to x to the power n, then dy by dx is x n x to the power n minus 1. When ex, same, it remains ex. When y is equal to ln x, at that time it's 1 by x. When y is equal to sin x, that time minus cos x. But when it is cos x, it becomes minus sin x. Right? Next, when y is equal to tan x, that time dy by dx is sec square x. When y is equal to cot x, that time dy by dx is minus cosec square x. When y is equal to sec x, at that point of time dy by dx is sec x tan x. When y is cosec x, that time minus cosec x cot x. Right? Now, for your clear understanding, let's practice some numericals. We'll do 4 numericals. Let's do it without wasting any time. Right. First one, let me think of a sum. Let's take y is equal to 2 to the power x 2x cube. Try to differentiate this with respect to x. Find the value of dy by dx. Pause the video and try to find out the answer. If you get it, it's very good. If you didn't get, no worries, you will be used to it. So dy by dx, as I told you, the formula for e to the power x, no sorry, the formula of x to the power n is n x to the power n minus 1. See here, 2 is a constant, x cube. This is a variation number. So when we differentiate, the first thing we do is we take the constant number at the first. Right, see, y is equal to this thing, so we can write it as d by d 2x cube by dx. Just simply I put the value of y over here. Fine. Dy by dx. So when we differentiate, we just take 2 out. As 2 is a constant, we take it out. So we can write 2 into d by dx of x cube. We learned in the formula that x to the power n differentiation is n x to the power n minus 1, right? So what we do here is we just put the formula 2 into, as the formula says, I write over here n x to the power n minus 1. So here n is what? N is 3 into 3 x will write x, and n minus 1. N is here 3, so 3 minus 1 is 2. So 2 into 3 x square. 2 3 is a 6 x square. So we can conclude that the differentiation of 2x cube is 6x square. Right. Now let's try a bit harder. Next question will go. Next question is y is equal to, let it be 3, y is equal to 3 by x. We can write this as 3 to the power x minus 1. Same thing, we will take the constant out first. So dy by dx, which is d of 3x to the power minus 1 by dx. We take the 3 out, we have d by dx of x to the power minus 1. Next we go 3 x to the power minus 1 means, so n comes out, n is a minus 1 comes out, x stays here, minus 1 is minus 2. Again I use the formula here, the same formula, refer to the same formula for this, same formula, right? So here just find it out, will means find easily. Minus 3 x minus 2. This is the final answer. I hope you got it. If you have any doubts, means don't worry, just go on, just practice more sums, and still if you have more doubts, you can contact me in the comment section. Next we come to number 3, where y is equal to, let's take a big equation now, x cube minus 6x square plus 2x plus 4, and we have to find dy by dx. So don't worry, just separate all these numbers and write them in the differential form. See, d by dx, first we take x cube, then minus, then we take d by d, or leave, just we take, we can like do it directly from here, like 3x, correct differentiation is 3x square, as we solved earlier, like that way. Then minus 6x square, as 6 is the constant, it comes out 2 in the power, so 2 plus 1 3, so minus of 6 into 2, one second, minus of 6 into 2 x to the power 1, right? Then plus 2x, 2 comes out, 2 into x to the power 0, it's 1, plus 4 dy, here 4 is the constant, so its value is 0, as we have seen earlier that differentiation of a constant is always 0. So dy by dx of 4 is always 0, so here it is, again it is 0. So on solving further, we get 3x square minus 12x plus 2. This is the final answer. Don't worry, this may seem hard, this may seem tiring to you. Don't worry, with practice, just you can do one thing, just find the differentiation of all these 4 things. 1 2, 3, 4. Just find the differentiation of all these four things separately. After this, do the thing given, like here minus plus minus minus plus plus plus. Okay, so find them and do it. I'm sure you'll find the same answer as I found over here. Now, one last sum. I'll do ending sum of this part 1 section. Next sum, let's take it. Let y be equal to 3x cube plus cos x plus 2ex, right? Dy by dx of 3x square, 3 will come out. 3 will come out here. N is 3, so n comes out 3x, n minus 1, here x is 3, so here square, plus c. I told you differentiation of cos x is minus sin x. So what we'll write here is simply minus sin x plus 2ex. Ex remains ex. So here it will remain the same, 2ex. Next, so 339, 9x square minus sin x plus 2ex. Don't worry, I'll come with more videos of these practice sums where all the doubts will be made clear. If you understood them, then please like the video and subscribe to my channel and share it to all your friends. I hope all your exams, ICC exams, went well. That's it. Thank you. Meet in the next video. Till then, take care. Goodbye.